Good evening and welcome to the Doherty Institute at the University of Melbourne and to this Convergence Science Network presentation. My name is Luan Ismail, I'm the convener of the network, and on behalf of its partners I extend a warm welcome to you this evening. As many of you have been to our events in the past know that we focus on biomedical research, particularly this convergence, the multidisciplinary approach to treating illnesses. And this evening we're going to do something a little different. We're going to focus not so much about the convergence of the sciences themselves and how they impact biomedical research. We're going to look at the convergence of science and the legal system, something very different. So we're fortunate to have 4 scientists from the Victorian Institute of Forensic Medicine. And this evening, they will take us through, I guess, some of the science of their work, understanding the critical role of forensic medicine. Without further ado, I'd like to invite the first speaker, Dr. Richard Bassett, who's the Deputy Director of the Institute.
First of all, I'd like to thank you for inviting us to come along and speak here this evening. It's lovely to be able to get out of the depths of the morgue and come and speak to real people who are kicking and living in the real world. This evening, there's 4 of us talking. All of them are colleagues of mine. My name's Richard Bassett. I am, as just been said, a Deputy Director and also Head of the Department of Forensic Medicine at Monash University. The other Deputy Director, Professor David Ranson, is talking as well. And in between we have our molecular biologist, Dadna Hartman, and forensic anthropologist, Dr. Soren Blau. And we'll each talk about our own individual disciplines. I'm a forensic dentist by training, and so I'll talk a little bit about the Institute in general, and then I'll focus on forensic odontology. Dadna will talk about DNA, Soren will talk about anthropology, and David will, as a forensic pathologist, will pull it all together and give some of the social context and legal context in the work that we do. So really, the Institute, as it exists, provides a voice from the grave to help protect the living. So not only do we deal with the usual sort of homicide cases and motor vehicle accidents, etc., but the majority of our cases are natural causes deaths due to natural disease, and we have a role in that space in looking at the causes of those deaths and any impact might be on living relatives of those people. So genetic cardiac conditions, for example, that we can detect at autopsy have impact on living relatives who can go and get genetic testing and undergo treatment to prevent their death. So we have a pretty wide social remit. We were established as an institute in about 1985. The building actually opened in about 1988, and we are an independent statutory authority. We have our own Act of Parliament, and at the same time we also became the Department of Forensic Medicine at Monash University. Started off with a staff of probably 1 or 2 back in 1988, being Stephen Cordner and David Ranson, and now we have a staff of a couple of hundred and lots of students, researchers, visitors come and visit us on a regular basis. So our main function is exactly that, to provide independent forensic medical services to the Victorian public and justice system. Currently we're doing about 6,500 medico-legal death investigations per annum. Not all of those end up in a full autopsy. Around about a little less than half, I guess, undergo full autopsy. The remainder, we're able to establish the cause of death without performing an invasive autopsy. We do lots of toxicology, we do lots of DNA testing, and our laboratories are fully functioning, well equipped and kind of state of the art really. A lot of our research is involved in community health and safety and prevention of injury and prevention of death. And we also do a lot of teaching as well as our research. So we teach the Masters of Forensic Medicine at Monash University, we teach the Medical Law program at Monash University, and we teach a whole host of medical registrars, students in all sorts of fields of health and safety. And last but not least, we're also the home of the Donor Tissue Bank of Victoria, where tissues are donated by deceased people to help increase the quality of life for living recipients. So that's sort of a snapshot of our services. So medico-legal death investigation, that's anthropology, pathology and odontology. Education and training, Department of Forensic Medicine. We have a DNA lab, a toxicology lab, a histology lab. We have a clinical forensic medicine service where we have clinicians who examine victims of sexual assault, domestic violence, family violence, etc., etc. Disaster victim identification is kind of a subset of a lot of these disciplines all rolled into one, and our donor tissue bank. We do homicide investigations. The number of homicides in Victoria is still somewhere between 60 and 70 a year. Never seems to vary very much over the years. So it's not a large amount of our work, but each case, of course, takes an enormous amount of time, including court appearances, etc., etc. And we work with all of these organisations, and we do homicide investigations in those countries overseas as well, who don't have the forensic medical capability that we do. We get involved in the occasional special project. I'm sure many of you will remember the identification of old Ned by his bones some years ago. We worked in conjunction with the Argentinian Anthropology team, and all of the people that you'll hear from tonight were involved in examining those remains and trying to reach an identity for the remains of Ned Kelly that were exhumed from the old Melbourne jail and then Pentridge prison. So the main substance of my talk, identification, essentially. As I said, we see about 6,500 deceased persons per year come through the doors of the Coroner's Court and the Victorian Institute of Forensic Medicine. The vast majority of those are identified visually, by visual recognition. There are a certain percentage, I think it's roughly about 700 cases a year, that can't be identified visually due to various degrees of trauma or burning or decomposition, and so they require a form of scientific identification. Dental record comparison, fingerprints, DNA, medical records, and occasionally, when we've got nothing else, it'll just be based on circumstantial evidence. Disaster victim identification is a subset of that, as in we use all of these methods in one large mass disaster. So identification really is based on the premise of our moral obligation to identify an individual. None of us want to die and be bulldozed into a pit in some unnamed country and never found, and our relatives never knowing that we're actually dead. Apart from that, there's all the legal issues that surround you. If you go missing and your body is not found, you may not be declared dead. If you're not declared dead, what happens to your life insurance? What happens to your assets? What happens to your young children? What happens to everything that you own? How do you deal with probate, etc., etc.? So there's this legal obligation to identify people, but also this really strong moral obligation that it's how we would like to be treated when we die. Some countries, of course, still treat death as a waste disposal problem, which we don't like to do. Remember I said that visual identification, the vast majority of our cases are visually identified. It's not a primary identifier. Visual identification is circumstantial, if you like. So there's no way to scientifically prove that the deceased person in front of you, just because you say it's them, that it is them. So for instance, poor old Marilyn, when she was deceased, she'd probably been dead for maybe 5 or 6 hours at that point. She hadn't been beaten, she hadn't been burned, nothing bad had happened to her. She'd died in her sleep, and that was her when she was alive. So you would have to know her extremely well to be able to visually recognise her as being Marilyn Monroe. And of course, in mass disaster situations, these sorts of ways that the locals sometimes try and help by putting photos of deceased people up on boards for the family members to walk up and down and look and see if they can recognise someone is completely unscientific. It's traumatising, it doesn't work, and it can result in misidentification. And of course, in a mass disaster, if you misidentify one person, you've immediately got 2 wrong, and the problem just compounds from there. So in mass disaster situations, we never rely on visual identification. It's always purely scientific means of ID. So from identification in general to forensic odontology specifically, it's simply dentistry really. And it's a comparative science. So we all go to the dentist, we all have x-rays taken, or I hope you do. You all have fillings done, or a lot of you will have. And all that stuff is recorded in dental notes and dental x-rays and dental charts. And we compare what you find ante-mortem to what you receive post-mortem to make a robust identification. Why are teeth so good? They're quite individual. Even without fillings, your mouth is quite individual. And if I have x-rays of your teeth when you're alive, all the young people out there will have had x-rays taken to see whether their wisdom teeth are straight. They might have had braces put on their teeth and had x-rays taken. They might have had plaster models made of their teeth for bleaching or for making sports mouth guards. All that stuff is a dental record. And because we have all these things and in our mouths, and they're all made individually, none of these fillings are made by machines, they're all handmade by your old dentist with his shaky hand on a Monday morning. And we can access those records and compare them, and of course, teeth are durable. So teeth will survive extraordinarily high temperatures, they will survive crematoria, they survive Black Saturday bushfires, and they will survive being buried in the ground for thousands of years. They'll survive immersion for hundreds of years. So when all else is gone, often the teeth are left. And also the restorations in those teeth are still there. So what we look for when we're trying to identify people are these sorts of things here. So all the various x-rays that you have taken, the plaster models of your teeth, the notes that a dentist might write that no one else can understand except another dentist. And also very useful to us and becoming increasingly useful is that extraordinarily happy universe of Facebook, where everybody smiles and there's a smiling photo out there for everyone who's got a Facebook account. So those smiling photographs can be used to identify you should the need ever arise. And some of the remains that we see are tiny. So tiny fragments, you can see the size of that scale up there. So some of these teeth are only 5 millimetres across, the burned crowns of teeth and the burnt roots of teeth. These can be used with the correct ante-mortem records, these can be used to identify you in the case of a very severe fire. So this is the sort of stuff we look for. These are the bread and butter, quite simple cases. It's an ante-mortem radiograph on the left, taken in somebody's dental surgery, a post-mortem radiograph on the right, taken in the mortuary. And it's quite easy to look at those two radiographs and see that they are of one and the same person. You don't need to be a fingerprint expert or a DNA scientist to interpret DNA profiles, it's very visual. So this is the sort of stuff we look for. It's not always that easy. Occasionally it can be quite difficult. So small fragmentary remains, that's a lower jawbone with some roots of teeth. There's a radiograph of that lower jawbone, and there's a radiograph of taken in a dental surgery during life. So comparing one to the other, you can look at that and say, well, there are similarities, but is there enough to conclude an identification? Probably not. So this is where we get the idea of this multidisciplinary work effort where we all work together with the anthropologists, with DNA people, with crime scene people, etc., to try and get enough information coalesced around a particular case to confirm an identity. We have help these days. One of the biggest boons to our work practices has been the institution of post-mortem CT scanning. So every deceased person that comes to our institute gets a full-body CT scan. And you can see an example of this is our general workstation that we have on our computers at work, where you can look at those deceased people and you can examine the CT scans through every single slice, any direction you like. You can do three-dimensional reconstructions, and incredibly important for pathology, so they can help diagnose causes of death without having to do an autopsy perhaps, but also looking for foreign objects and more specifically looking for things that will help identify you. Firstly and foremost, it's a digital permanent record of every person since 2005 who has died in the state of Victoria, has had a full body CT scan. So essentially we have a digital three-dimensional record of their body in our database. We can find fractures that are hard to see at autopsy. We can find causes of death, bleeding inside the skull. We can find prostheses for identification. We can look at teeth, and we can look at very subtle things, rib fractures in very young children that should not be there. So our CT scanner has been a wonderful boon to us and really has changed our practice. For identification and for dentistry in particular, you see wonderful images of dental work. Very expensive dental work, by the way. Implants with crown, root canal filling, crown, really expensive series of implants, so multiple thousands of dollars worth of dental work. We can see that really easily, and that makes our identification work quite simple. Occasionally when we get constellations of dental work like this, we don't even have to look at the body, we can identify people just from the CT scan imaging itself. I spoke about Facebook photos. This is an example of a real case. Post-mortem CT scan of a person's dentition, Facebook photograph of a person. ante-mortem Facebook photograph. So post-mortem CT scan, ante-mortem photograph, we can superimpose one set of teeth over another, and if teeth are slightly crooked or have imperfections that are noticeable from the front, we can match those imperfections and make an identification based on that. This is how we used to do superimposition. So getting a skull, putting it over a face, seeing if it fits. There's no science to it. It's kind of, I don't know, not far different from forensic artwork, I guess. Can help you eliminate people if you find a skull that's a particularly different shape to a head. We're doing some research now, getting a little bit more fancy using our CT scanner. This was from the Ned Kelly investigation, whereby we're CT scanning the death mask or bust that was taken of Ned Kelly's head after he was executed, CT scanning the skull that was thought to be his, and using some fancy software to put one CT scan inside another. And that one you can slice it all different directions and look and see whether the skull does indeed fit inside that head without any discordance. And you look at that, it looks like it fits pretty well, doesn't it? But that's actually Fred Deeming, and that skull is not Fred Deeming's, even though it looks like it fits. So there's a bit of science work to do yet. Identification continuing on, you have a lot of holes in your skull called sinuses. You have your maxillary sinus, your sphenoid sinus, your ethmoid sinus, they're all different shapes. And if you've been to a radiology clinic in life and had some CT scans of your skull taken or your sinuses taken because you have chronic sinusitis, we can use those CT scans and compare them to post-mortem CT scans and make an identification based on the shapes of the holes in your skull. We can estimate the age of people. So in the case where you've got multiple deaths of a number of children, car crash, say age 3, 5, 7, 9, kids in a car, how do you separate them all? You can separate them based on the development of their teeth inside their jaw. It follows a predictable pattern. We can relate it back to charts and we can give a pretty good idea of the age of people. Very useful for police. If a skeleton of a child is recovered, we can give an approximate age to that skeleton so the police know what age missing person they are looking for. They're not looking for the 20-year-old, they're looking for the 10-year-old. So it narrows their field of search. Injury description, this is particularly important in the field of anthropology, being able to describe injuries. Before we had our CT scanner, being able to visualise these injuries is quite difficult, required quite a bit of time-consuming, delicate, difficult dissection. You run the risk of moving fragments out of the original position because of the dissection. Whereas now with our CT scanner, we can visualise these things as they are. We can write reports on what bones are damaged, what direction the forces come from, the degree of force, etc., etc. I wonder whether I should talk about bite marks, but I am. Bite marks always gets a lot of press. It's always in, I don't know, CSI and all those shows, etc., etc. And really, bite marks are so varied in their appearance that, as you can see here, these are all bite marks of on various body parts of various severity, and really it's scientifically impossible to match a bite mark to a perpetrator. There's a number of reasons for it. The first reason is that most people's teeth are pretty similar. Most people have 2 central incisors, 2 lateral incisors, 2 canines, roughly the same width of arch shape, etc., etc. And also skin is a terrible impression material. So if I draw a circle on my arm and then go like that, it'll turn into an oval, completely different shape. So bite mark analysis is really fraught with danger, and all that we can really say about a bite mark is that it looks like a bite mark, probably made by an adult person or an adult-sized person, so maybe older than 13 or 14. Couldn't have been self-inflicted depending on where it was, and you can include or exclude a suspect. But when you see those court shows and when you see things from America about people being convicted on bite mark evidence, etc., etc., they're doing so without any science, and some of those convictions are incredibly unsafe. Disaster victim identification, which kind of pulls all of those identification sciences together, relies on anthropology, relies on odontology, relies on molecular biology, relies on forensic pathology, relies on police crime scene analysis, relies on circumstantial evidence, all of that being pulled together into one large mass fatality organisation. And this sort of stuff, we do it all over the world. Thailand, serious fires, exhumations of mass graves, etc., etc. We rely on the Interpol system, which as an institute we've been involved in disaster victim identification for a long, long time. I think the first time we were involved was probably in Kosovo, in the former Yugoslavia, back in the early to mid-90s. The Bali bombings, the Boxing Day tsunami, quite a few local ones, including most recently the DFO Essendon aeroplane crash and Burke Street. So we've had a lot of experience over a lot of years, and we export that experience to other countries. We do a lot of training overseas, as well as get called to these things when they happen. And when you're working in a mass disaster, conditions are interesting, to say the least. It's either freezing cold or boiling hot. You can be working in, you don't have the laboratory setting and the nice surroundings that we have down at South Bank. You might be working in the jungle under a tree, you might be working in a makeshift converted Buddhist temple, or a old and too crowded hospital mortuary. And these things are always incredibly crowded and quite difficult places to work, but incredibly rewarding, and kind of the reason why we do what we do, because without all the science involved, a lot of these people would never be identified, would never get back to their loved ones. And the end of our DVI process, the end of all of our identification process is basically this, where we present our identification findings to an identification board. Here in Victoria, it's the state coroner. If you're working overseas, it might be a military colonel or a police general or something like that. And we will present to them why I think that tooth is that tooth. Why I think that dental chart is that dental chart. Why I think that person with the post-mortem number is that person ante-mortem Mrs. L.A. And I explain those reasonings, and it's agreed by the coroner or by the board who's in control of any mass disaster, or in our day-to-day identification work down at the Institute, the state coroner. And once that identification is made, then the deceased person can be returned to their loved ones, and the grieving process can commence, I guess. I think that's enough from me. I'll hand over to Soren.
Thank you very much, and good evening. Thank you for the opportunity to come and talk with you briefly about forensic anthropology. Given the nature of the talk this evening, of course, I will be showing images of deceased individuals, namely skeletal remains, none of which are Indigenous remains. There's often confusion about why an anthropologist may be required in an institute of forensic medicine or at a crime scene, essentially because anthropology is defined as the study of humans. So if you go to university and you study anthropology, you might study any one of these four subjects. We're of course interested in physical anthropology, study of the human body, out of which came a small discipline, forensic anthropology. You can see here the definition. As forensic anthropologists, we're interested in material that in the first instance is believed to be human, and we examine this material to answer a number of questions. Essentially, we're interested in either the identification of that person or trying to provide some detail about what happened to this individual around the time of their death. Most forensic anthropologists do have experience in archaeology, and for that reason we understand what happens to an individual if they are unfortunately dumped on the surface or placed in clandestine graves. And we work closely in this context in Victoria but also overseas, working with investigators to understand whether a particular landscape may in fact have evidence of a deceased person. We might find anomalies. You can see some different colours here and shapes that indicate something has happened to that landscape. And for those of you who dig in the garden or are involved in renovations, you understand that any time you dig a hole, you will in fact change the nature of that landscape. And so we might find anomalies, but what it requires then is an intrusive investigation to really confirm or deny whether that anomaly contains evidence of human remains or other evidence. We really advocate the use of what are traditional forensic anthropology or archaeology techniques that provide detailed information about the association of information that might help identify that person, or gather information that is useful for the investigation, whether it has a criminal intent. Of course, we do study the actual physical body, but I do want to stress that most of our work does not involve the analysis of what you see here, sort of picture-perfect textbook human remains. What we mostly deal with is a range of differentially preserved human remains in varying conditions. So we might work with small fragments right up to the full skeleton. And it might be argued that actually our expertise is really understanding what a range of different forces, so whether that's time, burial, the way the person was killed, how that acts on the body. And really, you could say that by the time you call a forensic anthropologist, you're sort of at the end road. And these variables, the mechanism of death, the method of body disposal, where that individual ends up, so whether that's in a desert environment, is it indoors, outdoors, etc., the time between the individual's death and when that individual is recovered, and of course, as I've mentioned, who does that recovery. All of those variables really potentially limit the questions that we as experts can answer, and our responsibility as forensic anthropologists, pathologists and odontologists is really to obtain as much information as possible. So let's talk very quickly about what a forensic anthropologist might be asked to do, and again, I give you a snapshot here. It will very much depend on the question that's being posed by whether it's the investigator or the family. It may be in the first instance, is it actually bone? And you can see clearly here the images at the bottom are cases that have been collected and admitted to the Institute of Forensic Medicine, and you can see why. They look very much like teeth or parts of bone. None of these are in fact biological elements, and our experience is again to provide a timely information so we don't waste the coroner's time examining material that is in fact not human. It may be, is it actually human itself? We get an enormous number of cases of what are actually non-human remains, and we are, of course, mammals, so it's not surprising that there is confusion. It may be that it's clearly human in this case here, but again, we have a responsibility to provide information about whether, in fact, those human remains are actually of forensic significance, and you can appreciate in this context, we have ancestral remains, we might come across historical remains. And so in order to do that, we really work closely with police and in cases Aboriginal Victoria to look at the context in which these human remains are located and provide, again, timely advice around whether it's really of interest to the coroner to pursue the investigation. It may be a situation where, whether it's in examples such as house fires or plane crashes, you can see the image here with very fragmented remains is from the 2009 Victorian bushfires, or in examples not in our context, but this is a case from East Timor where we have mass burial. The forensic anthropologist can provide information about the numbers of individuals. So what is the minimum number of individuals that we might be dealing with in these cases? It may be a question of what's called a biological profile. I mentioned before, we've only got the hard tissue in many instances, and we need to try and give some information about what that person looked like when they were alive. There's 4 basic tenets of a biological profile, and you can see the list here. So where did that person originate from, so their ancestry, whether the person was male or female, and what is the estimated age. So not how long ago they died, but at what age did they die. And the 4th one being their stature, so the person's height. Now you can appreciate that none of those 4 elements will tell you the individual was, for example, John Brown. What this does really in many instances is provide lead generating information to police officers and really narrow that search. So if we look at this example here, mostly this work applies to long-term missing persons. This individual was found in bushland in Victoria, and there was no hypothesis about who this person was or what in fact they were doing there. You can see fully skeletonized. So the forensic anthropological assessment gives the police officer a snapshot of this individual. So in this case, we're not looking for example, an elderly Asian woman. It doesn't tell you the person is John Brown, but it allows the investigators to then go and do more detailed work to locate the individual, identify the individual. And this will be the same process whether it is, as I mentioned, in long-term missing persons, in disaster victim identifications, as Richard's already alluded to, where we work with what look like extremely fragmentary and not very interesting, but we can start to identify parts of the body that again help triage, if you want, down and provide information for the forensic pathologist and later to the molecular biologist. Again, in cases of investigations of political, religious or ethnic violence, it's the same. You have numerous, often hundreds of thousands of missing persons. That first analysis will be providing a snapshot of that biological profile. The other part of the role of a forensic anthropologist is to look at what we see as changes to that skeleton. Mostly we're interested in whether we see this as a leg bone here, a femur, you've got fragmentation, or in this case, the person's cranium. Whether that fragmentation is just a result of the person, for example, being buried for a long time, was it a result of the fact that someone clumsily recovered it, or does it actually have meaning around the person's manner or cause of death? So we come back to the real importance of the recovery phase. You can see that the collection of all fragments is vital to our work to really give a clear picture as possible. Now, I've talked very briefly about a whole range of contributions that forensic anthropologists might make, and we would make those, we make those contributions here in the state of Victoria. But of course, forensic anthropologists also have and continue to play a critical role in investigations of violations of human rights. I've talked about our role in the exhumation phase, and again, it's important to stress that the exhumation is a very important stage of the investigation process for families in contexts where their loved ones may have been missing for 10, possibly 20, many years. And so often it's the first time in these investigations that families see the possibility of finding the remains of their loved ones. Unlike in the context here in Victoria, we were quite removed when examining remains in the mortuary here at the Institute of Forensic Medicine. In these images here, some work the Institute was involved in East Timor. We work very closely with families, and again, we really believe they have the right to be amongst their loved ones once they are identified. And of course, forensic anthropology played a critical role in what was, or has been, described as the single largest forensic investigation undertaken in the former Yugoslavia. So the ICTY, the International Criminal Tribunal for the former Yugoslavia, was established in 1993 and really saw the evolution of forensic science evidence in international courts. And so we moved very much away from, if we reflect back to the work that was done in parts of Latin America, where evidence was based very much on eyewitness testimony, the physical evidence provided by the forensic anthropologists and archaeologists gave that physical nature which could no longer be disputed. So I do want to stress, as Richard has said, none of us work in isolation in our day-to-day work here, whether here in Victoria or overseas. We may work with a range of people. You can see here, mostly in our context, it's police, it may be army in other contexts. Certainly all of my forensic colleagues, pathologists, odontologists, molecular biologists, entomologists, lots of ologists. Maybe in our context again, Aboriginal affairs, and of course some families as well. I do want to stress that, you know, you get this picture in your mind's eye, but in fact we look far more like this. Thank you for your time, and I'll pass on to Dadna.
Thank you for the opportunity to talk to you today. And what I'll be presenting to you is the work that we do around using DNA for the identification of human remains. As you've heard previously, the Coroner's Court is required to investigate reportable deaths. Last year, we had over 6,000 cases admitted. And the Institute provides medical services to the Victorian public and justice system. And part of that, as we've heard, is ensuring that we identify the deceased before they are released to families. As Richard mentioned, most of these are identified by visual inspection, but there is a proportion, around 9% last year, that requires scientific identification. And that can be done, as we've heard, through dental records, fingerprints, but DNA. And I'll be concentrating on the work around DNA. The lab itself, it's quite small in comparison to what you might see at police forensic lab, where they're doing DNA work on criminal investigations. There's a team of 8 scientists working to assist in identifications. Most of this work is done through nuclear DNA analysis, where we look at a number of markers in the DNA. In our case, we look at 24 regions, which also includes sex determination. We also do what is known as mitochondrial DNA analysis in some cases. As it's been mentioned already, we do form part of the disaster victim identification effort, and this can be really any scenario where 2 or more individuals have been killed in an event. So it could be a multiple fatality in a car crash, or the Essendon plane coming down with 5 individuals, or much larger scale, such as the 2009 Victorian bushfires. We work very closely with our Victorian police colleagues, where we try to reconcile our unidentified remains with their long-term missing persons records. And we also provide DNA testing services to other jurisdictions, particularly around the mitochondrial DNA analysis, as this is a methodology that few labs around Australia employ. As you can see from the graph, the number of samples that we analyse each year increases steadily. Most of these samples are coronial-based cases. As I mentioned, we do some work for external agencies as well as Victoria Police. So what is DNA? Well, it's a complex chemical. It is a biological material, so it is affected, it can degrade, it doesn't stay there forever. It contains all the information that is needed to maintain an organism. It's made up of a code of bases or building blocks, for which the order of sequence of those building blocks determines the information that is available in that DNA. It is a primary mode of inheritance for all of us. And there are 2 types of DNA. Most of you would be familiar with nuclear DNA, and there's also what is known as mitochondrial DNA. So nuclear DNA, as the name suggests, can be found in your nucleus. There's 1 copy per cell. It's quite large. It is structured into chromosomes, these things that look like large X's. There are 23 pairs of chromosomes in a cell, including those that determine sex. Now, nuclear DNA is inherited both from your parents, 1 set from your mother and 1 set from your father. Mitochondrial DNA, in comparison, is quite small. It's circular in size. There are many mitochondria per cell, and there are many of these circular genomes inside a mitochondria. Because of the compartmentalisation of the mitochondria, it's a double membrane organelle, it's quite stable. So in comparison to nuclear DNA, we've got lots of copies of mitochondrial DNA floating around. And what's interesting is that mitochondrial DNA is maternally inherited. So it can get passed down from the mother to all her children, regardless of gender, but it's only the daughters that then pass out that same mitochondrial DNA through. So it's a really useful tool to be able to trace one's lineage through a number of generations. And it's the technique that we used during the identification of Ned Kelly. So when we talk about nuclear DNA profiling, it's about looking at regions that are known as short tandem repeats. These are regions that are found in non-coding parts of your DNA. They vary in the length of these repeats. So for example here, that's a repeat unit. You could have 10, 20, 30 of those repeats. And it's that length and over a number of regions that we look at that gives you your unique DNA profile. So we use something that's known as PCR, to make lots of copies of one fragment of DNA because we need high enough quantities of the DNA fragments in order to visualize them. Once we have enough of the amplified product, we do what is known as gel electrophoresis using a CE instrument that separates the fragments. Shown here are a number of regions of DNA in a profile that you might see, where we've got two alleles, one coming from mum, one coming from dad, or perhaps we get the same allele from our mum and dad. And it's that combination of those 24 regions that we look at that give us your DNA profile. Mitochondrial DNA, very similar. We target a region of the mitochondrial genome that's the control region. Again, it's not around the coding genes. Again, we use PCR to make lots of copies of the mitochondrial fragments. We then ensure that we've got enough of that material to be able to sequence. And it's the sequence, it's the actual order of each base in that mitochondrial DNA fragment that gives us your mitochondrial DNA profile. So for the purposes of identification, we mostly use nuclear DNA comparisons around kinship, where we have a sample that's been collected from the deceased individual. We get a DNA profile and compare that to a profile that's been obtained from a sample that's been given by a relative. Now, this could be a parent or a child of that deceased person. If the DNA profiles match, for example, is this DNA profile from a parent or child of this individual, then we could say that the samples have derived from a biological relative, and therefore we can use that to establish ID. If they don't match, however, it then implies that these samples have come from individuals that are not biologically related, and therefore ID is not established. It's not often that that happens, but that's what we do. Similarly, we can use mitochondrial DNA, and the times that we use mitochondrial DNA is when we can't recover sufficient quantities of nuclear DNA from our deceased samples. Again, we would compare a sample, a mitochondrial profile from the deceased person to one that's been provided from a maternal relative. A match would imply that these are biological relatives, and therefore we can use that for ID. If there's no match, again, it would imply that these are not maternally related individuals. Mitochondrial DNA is not as informative as nuclear DNA because different family members, maternal relatives from the one family, will share the same mitochondrial profile. So all we can do is either include or exclude someone as being a maternal relative. We can't definitely say this is your child or this is your parent using mitochondrial DNA. The sort of samples that we see will range depending on the condition of the body. Most of the samples from the deceased individuals that we get in the lab will range from blood stains, tissues, toenail clippings, bones, and bladder swabs where there's been a level of incineration. So we extract DNA from these sort of samples, which can be quite compromised with regards to the quantity and quality of the DNA. And these are compared to reference samples that are provided by families, and that's usually a buccal swab that can be collected either by the family attending police or the family attending the institute. So our workflow looks something like this. We will do DNA extraction either using a commercially available kit on an instrument, or perhaps we're using an organic extraction manually. The DNA extract can then go through a nuclear DNA analysis pipeline where we'll do quant to determine how much DNA we have present. We would then do DNA profiling using commercially available kits to then give us what we term a nuclear DNA profile. Or we could do a mitochondrial DNA analysis pipeline. Again, we'll do a quant step to see how much mitochondrial DNA we have. We will do sequencing to then determine the specific base combination to give us a mitochondrial DNA profile. The next few slides, I'd like to concentrate on missing persons. This is one aspect of the work that we do. You may be aware that we might have quite a number of unidentified remains at the Institute where we don't know who these individuals are. We aim to obtain a DNA profile from these remains, both nuclear and mito if possible. We then add these to what is known as the Victorian Missing Persons DNA database. We are custodians on behalf of Victoria Police of the database, where we upload our unidentified remain DNA samples as well as our family reference samples. Families of missing persons who have provided buccal swabs in the hope that one day they can be matched to remains, and therefore they know what has happened to their loved one. At present, we have about 40 records of unidentified remains that have been compared to 300 records of family members. So for us, we'll get a sample, we'll do DNA profiling from that deceased sample, add it to the database, screen it against those family reference samples in the hope that we get a match. DNA would play just a part of that identification. We would then work closely with our colleagues to see whether the anthropology, dental records, circumstantial evidence all fit in to make that ID. Unfortunately, it's not often that we get a match. The case that I want to show you is an example of where we have been able to do an identification. We had remains that were located in bushland. Anthropology told us that he was an adult Caucasian male, but there was no information regarding the possible identity of this individual. We were able to obtain both nuclear and mitochondrial DNA profiling, which we then added to the Victorian Missing Persons database. In that database, we had a profile from a mother and a daughter of a missing person that had been provided in the hope that one day they could find their loved one. And in this case, the deceased matched those two profiles. So DNA was able to bring these two cases together. We then brought in the anthropological examination, odontology, and any other information we had to build a case that enabled the identification of this long-term missing person who had been missing for over 20 years and identify them. But as I said, most of that doesn't happen regularly. We've had probably 2 cold cases that we've been able to solve since we've had the database. So where to from now? If we have DNA profiles but we don't match them to family members, what else can we do? Otherwise, from a DNA point of view, we can't pursue the investigation any further. You may have heard the term massive parallel sequencing or next-gen sequencing, next-generation sequencing, and it's the technique that enables the DNA sequence of many fragments of DNA at once. So it really amplifies the amount of data that we can generate. And it also enables us to look at sequences that predict things like physical appearance, so eye colour, hair colour, geographical ancestry, as well as looking at ID markers that we've used with our conventional STR profiling. So in the case that I presented before, we know who this individual is through conventional profiling. He was matched to a mother and daughter. We know what he looked like at the time of disappearance: light brown hair, blue eyes, fair complexion, medium build, European ancestry. When we put the DNA through the phenotypic and ancestry panel, we could see that this individual, blue eyes, light brown hair, European ancestry. So we can see how DNA is now helping us build a profile of what these individuals might look like. In this case, where we have unidentified remains that were located in the late 70s, at the time we didn't have DNA profiling, so these remains were buried as an unknown individual. They were then re-exhumed in 2011. Again, a male individual. We failed to get nuclear DNA profiling, but it's not really surprising given the conditions of the remain. As I said, DNA is a biological material. It can degrade, so there are times where we are not successful at being able to get nuclear DNA information. We were able to get a mitochondrial profile. However, it did not match any of the family members that we had on the missing persons database. So from a DNA point of view, we could not assist any further. However, now with the phenotypic and ancestry analysis we can do, we could see that this individual has brown eyes, dark black hair, European, in particular, strong Irish and Hungarian descent. And again, through mitochondrial DNA analysis, through the maternal line, again, a strong European. So you can imagine that we could be providing our police investigators with additional information that they can go back to their missing person records and start looking for individuals that perhaps match this description. So hopefully I've been able to give you a snapshot of the sort of things that we do with our DNA analysis, and none of this would be possible without the hard work of the guys in the lab. So I thank them and thank you for your patience and time. Thank you.
Well, thank you very much for inviting me to talk. You've had a lot of hard science. Now things are going to get a bit softer. I won't say warm and cuddly, but certainly softer. I'm going to talk a little bit about forensic medicine, truth and mythology. I'm going to talk a little bit about the coroner's jurisdiction. How does it fit into the social structures of what we are and how we operate in Victoria and Australia? And I'll talk a little bit about the end and where we get that very strong interface between society and the community and what we do, and that strong interface often is around the area of mass disasters and how we as a community respond to those. So that's just to give you a flow of where I'm going. To communicate, you need to understand the myths, because we communicate by mythology. And if you want to change those myths, you need to communicate. So there are some really interesting things that we're starting to do at the Institute about getting that communication put together. So, for example, we've used open theatre. We've actually had our mortuary rooms as a theatre for members of the public to come in, and we've performed a play for them, which actually structures and explains some of the work we do. So why is this important? Why do we need to know that? Because we need to get the facts right. Our job as scientists is about getting the facts right, but our facts are not there just for other scientists. They're for the community. If the community doesn't understand the context in which we did that work, especially when they get onto a jury in a courtroom, then they're going to be approaching what we've done through the wrong window. They've been thinking about it the wrong way. And it is so easy to get the facts wrong. Here's a really lovely example of how well the media does, or how badly the media does. This is obviously the Royal Commission, Institutional Child Abuse, and the Vicar General, Dr. David Ranson, said this, and they put my picture up on the AAP website. Now, I happen to know Dr. David Ranson, who is indeed the Vicar General, and he is a very nice man, he was very amused by it, I was very amused by it. We get each other's emails occasionally. So, but it's so easy for somebody to make the assumption. The journalists didn't check their facts. They just looked up David Ranson on Google Images, and there I was, the first one. I just sneak in before the priest. So I was the one that was picked. Okay? But if we don't get those things right, then there's a tremendous risk we're going to confuse the community, or people will start not believing what we do. Because what we do was very, very important in terms of community engagement years ago. Before media, before television, before cinema, what did people do for entertainment? They were in their parlour and they might play a few games and sing songs and things like that. Outside the home, they went to the courtroom to see the famous trials. Packed out. People lining the streets, getting in there, wanting to see, because it was a piece of exciting theatre and it was free. So what are these myths that we need to deal with? Well, I've tried to pick a few wrong messages that seem to be out there. So pathologists, which I am one, are not doctors. No, we are, or at least the ones that do the work that I do are. Coroners perform autopsies. Nope, not in this country. Okay? Coroners are doctors. Nope, not in this country. Detectives look over the pathologist's shoulder. I get detectives out of the room. I want detectives nowhere near me when I'm doing an autopsy. They only just tread on things and get in your way. Forensic pathologists don't like seeing living patients. Actually, we see quite a few living patients. We see families of deceased people. We sit down with them. We explain the findings. Engaging with the family is a very important part of what we do. So it's not true that we don't like live patients. Well, there might be some of my colleagues who don't like live patients, but, you know, as a general rule, we don't talk to the corpse during the autopsy. I mean, Ducky is great on NCIS, and I can unfortunately remember him from Man from Uncle, which always confuses me. But, you know, we don't talk to corpses. We don't crack black jokes. We've got a busy job to do. Busy morning, 15, 20 patients being examined, perhaps having autopsies. That's a busy morning. And we've got a team to do that. We haven't got a lot of time for those sorts of things. We don't say things to discuss mortuary visitors. And actually, we're not particularly interested in the outcomes of the trials which we give evidence. But I don't usually find out much about what happens at a trial unless I happen to be watching the news or a policeman actually emails me. So we're not actually interested in that outcome aspect. We're interested in getting our science right and getting that science communicated appropriately in the courtroom. And I love being cross-examined. There is no better day than me going to court and being cross-examined. It is fantastic. It is really great. I want to do that. I say that very particularly in the hope there are barristers in the audience. And I always say that groups of barristers, because one of the techniques of a barrister is to keep the doctor there in the witness box until they're tired of it. But as I said, it's lovely. I can turn my phone off. My secretary can't get at me. I can have a nice lunch in town. It's a really good day out, from my point of view. We don't go out interrogate suspects. I keep my way well away from suspects. We don't lead the investigation of the crime. The police investigate the crime. We're an agent of their investigation. Police don't lead the investigation of deaths. It's actually the coroner that leads the investigation of a death. Pathologists can determine the cause of death on immediate arrival at the scene, sniffing the body, using laser-enhanced 3D. No, we don't do any of those things. Actually, you know, I don't need a lot of instruments to really do my job. A thick pair of rubber gloves, a knife, a pair of scissors, a saw. I could buy those in Bunnings, to be quite honest, and I would have 95% of the tools I need to do my job. Now, I'm very glad I've got a few other tools, but that's all I really need in a practical, physical sense. I told you we're going to get to soft science here. So, what do TV shows do? Why do they cause this big problem for me? I used to be able to go into court, 20 years ago and say I'm a forensic pathologist. People had a rough idea of what I did. Now I have to go into court and say I'm a forensic pathologist and explain what a forensic pathologist really does, because the media shows condense things. So we have a TV audience that usually only follows 3 or 4 main characters in a show. So everything that will be done by 20 people in our building has to be done by 2 or 3 people. Tests that might take 3 weeks to get back have to come back after the ad break. The physical spaces, they all have to be together, and they're all separated by glass partitions so you can see through. Well, that's not exactly ideal in a mortuary, and we don't have that sort of structure, and we can't just walk into other people's labs. We have key cards that control our access to all those rooms, and we're recorded every single place we go. Give them what they imagine happens rather than really happens. I work for a few TV shows, I'll show you. But when I come up with ideas for them, they say, oh, nobody would believe that. I said, but that happens regularly. Oh, no, but no one would believe it, so we can't put it in the TV show. Okay, so that sort of thing. So you give people, they want a little bit of blood and guts, but not around tea time. And they strategically place the adverts really to give the pauses in the storyline. But you never put a dog food commercial in an ad break in a mortuary scene. And that's what the producers told me. So the curse of the media, these are the sorts of shows, and there are others which influence what people think about what we do. I've been involved in quite a few of those shows as a medical advisor. It is really fascinating work with the writers, and to be fair, many of these shows, the writers want to get it right, but they do have strong industry constraints about what they can actually do. So who are we? Well, we're medical practitioners, we're medical specialists, we're death scene examiners and dead body examiners clearly as forensic pathologists, and we're also experienced witnesses. But it's a long haul to get there. It's 15 years plus in postgraduate and graduate study in order to get to that position. And that means quite a lot of dedication to working in an environment which is not necessarily the same environment that other doctors are able to work in during their professional training. And of course, we are as a pathologist intrinsically involved in understanding death in our community, where and how and the circumstance in which death occurs. Because what we do is we can look at these sort of pairs. There are intended deaths in our community, unintended deaths, expected, unexpected, avoidable, unavoidable. And we can look at those, and those are some of the most critical decisions we can make as a community, because we want to work out how a person died for the sorts of reasons that Richard was talking about. We need to understand who is in our society, who's left our society. That has financial reasons, but strong family and social reasons. Who investigates most deaths in our community? Answer is the general practitioner. Who oversees the general practitioner in writing all those death certificates? Answer, nobody. That's how Shipman was able to operate in the United Kingdom, effectively. Now, we do have some little bit of filters in Australia, and certainly in Victoria, we have a good relationship with birth, deaths and marriages, who register these certificates, and they send about 600 or so certificates to us each year because the GP has written something that looks like it should have been reportable to the coroner. And in many cases, it was. So the coroner comes in as a partial solution to all of these issues, and the coroner, as Charles Dickens describes it, frequents more public houses than any man alive. Now, why did the coroner say that? And that was true in Melbourne, because in those days, the only place that had a call room was the pub. And in Melbourne, every publican was required to store a body on payment of £1. And all bodies were stored in pubs, which meant that the inquest was also conducted in the bar of the pub. It was a terrible upset when one was held in the brothel next door, and they wrote to the governor, and it was all terrible business. Anyway, but we have a much more official and pleasant environment in which to give our evidence in court in Victoria. We have a coroner's court structure, an independent court in Victoria now, and a Coroner's Act which clearly says that the coroner's about preventing deaths and fires, administration justice, and public health and safety. And the coroners are all judges, they're all lawyers, they're all barristers, they're all solicitors. They are basically apply the legal process of investigation, and to do that they take the evidence from the scientists, from the anthropologists, from the dentists, from the pathology people, from the police. They put all of that material together in a legal investigatory process. And of course that means that coroners don't do autopsies despite what Channel 7 says regularly on the news. For that they rely on the forensic pathologists, and our job is to give them the facts as well as give them our opinion as to what those facts mean. So coroner's legislation, this is what a coroner has to find. The person's died, and what's the identity of that person, when and where they died, the cause and circumstances. They can hold a formal inquest, and these days in Victoria, they can publish the recommendations out of their inquest on the internet, and they can require the organisation against whom a recommendation is made to respond in writing, and they can put that on the internet for all to see. Worth going and visiting the website and having a look at some of these findings and some of the responses that organisations have made to them. It closes the loop and it holds out a public accountability. The coroner can't enforce anything, but they can present it for all to see, and with strong media engagement, that can be very, very influential on organisations, corporations, politicians, and so on and so forth. As mentioned earlier, the vast majority of cases we deal with are natural causes deaths. Even the homicide at 3%, that's the homicide cases as reported to us. It's actually about 1%. Because when we look at those suspicious cases, many of them will turn out, in fact, not to be suspicious. But people forget suicides. They forget the accidents, a broad range of accidents, not just motor vehicle accidents, but industrial accidents, a really important part of protecting the community from further similar episodes. So coroners investigate reportable deaths. I'm not even going to touch on reviewable deaths, which are another class altogether that nobody understands. But essentially, it's really deaths that have occurred that are not due to natural causes or with the administration of the death process, that is a death certificate, known who they are, and things like that, hasn't yet been able to be sorted out. Where does that come into its really big social context? And that's in the situation of mass disaster and a mass fatality incident, where we have huge community concerns. And you just have to think about the Grenfell fire in London and that tower block, and just think through the framework of what you've heard this evening, what that will mean for the people, what that will mean for the community. Where were the concerns? What did you hear on the news about what people's concerns are? How they were treated? How the people who evacuated from the building were treated? That was their concerns. We haven't yet heard media concerns really of the people who are missing people. A few, but not very many. Those will come out later, and I'll talk a little bit at the end just about how you manage that. Australia's had many mass disasters, and certainly the heat wave in 2009 and its consequence, bushfire at the end of it, was a very major one. I call the heat wave a disaster because we had probably in excess of 300 deaths over and above we would have expected that time of year. So we went into the Black Saturday bushfires with this excess of ordinary workload that had come in. And that created a really big issue that you have in any mass disaster, and that is that the daily work goes on regardless of the disaster. People still die of motor vehicle accidents, of homicides. Our emergency departments are still full of people who've fallen off their bike, who've cut themselves, etc. So these are important things. How do you manage a disaster and maintain your ordinary capacity? So preparedness is critical. And emergency management at Victoria, where we work very closely on the fatality management plans, are really planning for all of these sorts of disasters. They are part of what we expect to happen. We hope they won't, but we expect them to. And that means we are prepared and we have the capacity built up to respond to those. And as I said, maintaining operations, routine operations, is a critical part of that. So the bushfire response was a good example. That's our mortuary working during that crisis. It was a calm and quiet and peaceful place, despite what you might think an environment like that would be like. Huge issues in terms of what happened in the fire, but wasn't just in the mortuary. We went out to 145 scenes. 86 of those required revisits after the buildings had been dismantled enough to get in to see what might be inside the building. We had pets. We had families who moved one house to the other, so you couldn't guarantee that what was in one house were the occupants of that house normally. So there's a whole heap of things like that form part of the complexity of managing those issues. When you have very, very ash and fragmented remains which are commingled, you have to give every single tissue that you recover a separate number. And then you have to put all of those numbers together and match individuals and hand all of those remains back to the family. That is a challenging task. And there's a big political question about how far do you go? What size of tissue do you finish up identifying? And are there tissues that you will not identify because it's impractical? These are, at the end, political decisions as much as professional decisions, but we have to make them. Then you get something more recent, the Burke Street Mall incident, where you have really a focus on many of the living, but you've also got a focus of managing both the living who are injured and the dead, how you respond at the scene to that, how you engage with the community, how you talk to the community, how you explain to the community what will happen. When someone says, well, I know that was Auntie whatever's there, why can't I have Auntie back now? There's only X people, whatever. So, but it's actually doing the job right, getting everything right, because what we've got is both a humanitarian and a judicial exercise. So we're doing humanitarian work, but we've got to do it in a way that meets the requirements of the justice system in terms of evidence collection for the court, so that that evidence becomes admissible in the court proceedings and can't be thrown out. And that's a very important part of what the forensic pathologist tries to do. So when we're doing that work, we follow detailed protocols we've worked out in Interpol over the years. They're protocols that talk about the scene work, the mortuary work, post-mortem data, ante-mortem data collection about the person in their life, reconciliation, matching those things together, as Richard said, and then debriefing of all of the personnel involved, and eventually repatriation, sometimes internationally, to bring those people back. The people we use are the people you've heard from tonight, the pathologists, the molecular biologists, the anthropologists, the dentists, and the fingerprint people. We're all involved in that work, and we follow those standards. It's a complex task. People always want it quickly. Well, you can have it quickly if you can mobilise massive resources to do that at a moment's notice. But that's not normally possible. We need it to be good, therefore we need to take time. And it's much faster these days than it used to be when DNA tests might take 3 weeks, 6 weeks, whatever. Now we get results in days or hours. So things are improving, but you've still got to do it right. And the multinational issues that now occur, so the work with MH17, where you have multiple nationalities involved, complicates this enormously. No longer do people have dental records in one country. They have dental records in 2 or 3 countries. And somehow that's got to be put together to get an integrated ante-mortem data set which you can compare against post-mortem. So there's some increased complexity. Where does a person get repatriated to? These are important issues when you have this multinational. As far as engaging the community, we have processes that are both formal, and you see some examples of those formal processes in MH17, and we have the processes that are informal. So formal is a very, very important part of showing the community the engagements there. And the way in which that was done with appropriate ceremony and dignity is critical in keeping a community engaged at a terribly difficult time. But informal ceremony is just as important. People came along, left flowers, left gifts outside the gates at Hilversum, where the mortuary was, every night. Every evening, whole families would come on their bikes. They will be visiting, they will be leaving flowers, they'd be leaving messages. That informal process was actively supported and is, I think, a critical part of how a community can respond and can engage its own community in the process. And we tried to do the same thing when bodies came back. It's really important, how do you communicate with the community generally? And the sort of questions that are always there. Is my loved one dead? When will I get them back? Will everyone be identified? Who is at fault? What do I do now? What do I do? I think I've lost my daughter, my father. What do I do? And so actually putting representatives that can work with people, and the AFP are very good at this, with the family liaison officers who really work with the families and support them all through the process. And again, we did the similar thing in family support with MH17, so we had family meetings that took place before the inquests, so families knew what to expect and they could have, in fact, most of their questions answered before the inquest process happened. And again, in that process, looking at their well-being, not just the families actually, but the community and our staff who are doing the work, because they're also at risk in that process. Well, that's really what I want to talk about how forensic pathology works with a community to solve community issues and to ensure the community is informed in a way that it feels it can rely upon the information that's presented to court from the experts that you've heard from tonight, because that is a critical part of our jury system. Thank you.
Well, thank you very much, Richard, David, Soren and Dadna, for that intriguing overview into the incredible work that you do and very important work that you do. So we're going to take some questions from the audience.
Thanks for great talks. Look, in relation to the DNA component of the talk, I was just interested to understand whether in the current age where personal profiling and ancestry collection of DNA and lineage investigations on a personal level with next-gen sequencing, if that is applicable or available to you to apply to unsolved cases or unidentified bodies to try and link to familial descendants?
Yes. So at the moment, we are in the research or validation phase for massive parallel sequencing, where we're looking at markers for phenotypic ancestry and ID, so that we can get more information to be able to provide our investigators to assist us, whether it be, in our case, missing person investigations, so that we can tell them perhaps that they're looking for a person with a particular ancestry, a particular look about them, so they can go back to their missing person cases and start looking for those features. So yes, we are definitely looking to apply that as part of the workflow, in addition to our conventional STR and mitochondrial.
Have you sequenced the same regions from, say, Ancestry.com or MyHeritage and these things, and you can link into those databases?
I guess it comes to how those samples and analysis has been done. For us, we have to do it under a particular guidelines or accreditation. So for us, it would probably be, we would resample or get additional information from family members to put through the same process, as opposed to getting DNA profiles from an agency where we can't verify where those profiles or how they've been generated.
It links to what we were saying about judicial and humanitarian.
Yes.
There's a lot we can do, but if we want to do it in a way that's going to be meaningful in court and can be given in evidence, we have to make sure that all the steps have followed those sorts of guidelines.
What's a buccal swab?
Mouth swab. So essentially, it's a collection of cheek cells. Yes.
Remains are not identified, let's say, and what percentage of missing people are not ever matched?
Well, at the moment, we have 44 unidentified remains that we haven't been able to match, and that's probably because we haven't got the appropriate reference samples as comparisons. We're hoping that in the not so distant future, we might be able to go nationally and start looking for family members outside of our jurisdiction, because obviously missing persons can travel interstate. So we're hoping that as we move to a more national approach, that we'll be able to identify some of these remains that we have. So
The approach is very much just
within the state,
outside.
unless there are specific requests to have a particular case looked against our data set, but we're not that far from being able to do national searches, both at the DNA level as well as dental records and other information.
And the number of, like the percentage of missing people or deceased people that remain unidentified is very low. So if that 44 is...
Over a number of decades.
Yeah, over say
Thousands and
30
thousands of
years or
cases.
something, that there's only 44 people unidentified.
Yes.
Most are identified. Black Saturday, we identified everybody.
Yeah.
The Thai tsunami, I think there was about 5,000 deceased individuals in Thailand, part of that operation. We were over there on and off for a year. At the end, I think there's about 500 unidentified people left, and the thinking is most of those are itinerant illegal immigrants who've come from Cambodia and neighbouring countries who have no family members, no records, maybe their own family didn't even know they were there, etc. So the vast majority of people we're able to identify eventually.
It's the nature of doing open and closed disasters. We talk about a closed disaster is one where you know who are missing, absolutely. A plane crash, you know everyone who's on the plane, you can check the CCTV in the airport, everything at that level. An open is when you don't know that. And any other sort of disaster where you don't have those inventories puts us into a problem because you don't know who's come in, where they've come from, who was staying there. That information can come in time, but it may take over months for that information on the total missing to be known. And then you've got to get ante-mortem or comparison samples, and that can, for some situations, that can be very difficult.
I think at the beginning of Black Saturday, there was 173 deceased people, but I think within 2 or 3 days there were 3,000 missing persons reports registered. So that's people who thought they might have been in the area at the time and hadn't heard from them since. A lot of them were repeat reports from different people about the same person, etc., etc. So initially the information can be incredibly confusing, and it can take a number of days or weeks to settle on an actual victim manifest in one of those open disasters.
So the morality and humanitarian efforts of forensic investigation is that it seems to be a running theme throughout all the speeches, but when the public was mentioned, it seemed like a very passive effort on the public's stance that when an investigation happens, then you go to the communities, and then communities wait and have people come to them and ask them, to start filing databases of people who are missing and stuff like that. But as far as the rights of the public to request investigations, and I'm also thinking, I understand that there's quite a heavy judicial responsibility for forensic investigations, but I'm thinking of extreme cases of like Chiapas in Mexico with those students that went disappearing, and in the London fires and stuff like that. What right does the public have to come to investigators like yourself and request that more efforts are being made, or because it does seem there's this passive relationship between the police and judicial responsibilities, where you speak of needing to identify the dead and then releasing them to the families. Whereas, so what rights do we have as a public, and then how do we access
it's a really interesting question. I mean, if I speak outside of the state of Victoria, if we looked, back in the mid-80s in Argentina, it was once Argentina had regained democracy that it was the push from the public that led to enormous amounts of forensic investigation. That is a different, approach than what we see here in Victoria. It's not to say that couldn't happen, but, I don't know if you want to speak more to that.
I think the issue of any person can report a death to the coroner. Any person can. There's no requirements to be a police officer or a doctor. And the coroner can look at that and see whether it is a reportable death, and if it is, it will be investigated. It is simple as that. Our legislation means that the coroner has no choice but to investigate those processes. But that sort of rigid system and the infrastructure to allow that investigation to take place in a scientific framework exists strongly here, but doesn't exist strongly in other contexts and in other jurisdictions. And you're absolutely right that if you don't have the political and legislative structures that allow that to take place, and you don't have the technical infrastructure and the skill sets, then within that particular jurisdiction, then you will not achieve those outputs. That's why organisations, like the International Red Cross and we have the programme on the missing, are engaged very strongly in those endeavours to try to ensure that resources are made available, to at least make sure that the technical resource will always be there.
But as you said, it is often very much around political will. So.
Sure.
Thanks for your presentations, love them. The wrongful conviction of Lindy Chamberlain showed forensic science in a really bad light. I guess you always get this question. But apart from the DNA resources available, what have been the big changes in quality that ensure that wouldn't happen today?
Sure. I suppose from an operational point of view, the accreditation system, so NATA, National Association of Testing Authorities, now effectively accredits every single forensic laboratory as a program. That wasn't the sort of program that was available in those days. The more standardisation of training programs, both at a tertiary level, also ensures, I think, a more even playing field of science. You will always get odd people who don't follow protocols, and a system should be designed to pick those up, and for the most part they are. I think also the sort of the single signatory to a report we've been moving away from that over the years. So, even when a report goes out at a forensic pathology level now, if it has a case going for court, it always has a second pathologist who has reviewed that case before it goes out. And that's true for laboratory checking at all those sorts of levels. So those procedures have gradually got better over the years, I think, and I'm not saying they can't be improved. I think it's a process of continuous improvement, but they are certainly of a completely different order. Even in my lifetime working in forensic pathology over the last 25, 30 years, a completely different order of accountability is built in than was there all those years ago.
We also have the National Institute of Forensic Sciences, which supports specialist advisory groups. So each of our disciplines is represented, and the practitioners are expected to attend meetings. And we're trying to get away from anyone calling themselves, for example, a forensic anthropologist and going to court to have a recognised body under the National Institute of Forensic Science.
And I think it's, in the last 20 years or so at least, it's moving away from purely opinion evidence where the doctor can stand up in court and say, I believe this bite mark is without doubt made by this person here. How do you know that, doctor? Because I've been doing this for 20 years and I know. So that has been happening until quite recently in America. There's still bite mark cases. As early as the last one I read, I think was about 2012, someone convicted of a bite mark that was clearly completely unscientific and at risk of a wrongful conviction. Now we try and make sure that we have a proper evidence base to the opinions that we're giving. Some of it's still purely evidence, but we try and get as much as we can of an evidence base through our research, our PhD students, our association with Monash University, etc., to try and ensure that we're increasing our evidence base all the time so that less and less of what we say is just based on our years of experience, but more on this research paper and that research paper and that research paper.
We talk about factualising opinion, and I think that's a really important step.
You'll let me have two quick questions. So the first one is about the DNA, and you had 0.49, 0.99, so I assume that was a probability that
yes.
was correct.
Yes.
All right, and the second one is, where does the money come from when you have a major disaster and then suddenly you have to
Just
find
falls out of the skies. We get to work and all of a sudden we've got people offering us CT scanners and new cameras and new this and new that.
Yeah,
So
it is fascinating because nobody wants to spend money on what hasn't happened yet.
Yes.
And I know, when I'm talking to some of the FBI over the years, they worked on a solid funding basis, which was, as soon as a disaster happens, we go out and order everything we need for the next disaster, because none of it will arrive for the one we're ordering it for. And it's that sort of rolling basis. Having said that, I must say that we have always been actively supported in what we've needed in the event of disasters. But, it is hard to get people to fund things that might happen.
And we do find that our suppliers are very supportive, so at a time of need they will come and ask you if you need additional equipment, whether it be fridges for storing samples or processing. So we're very fortunate that we've had that support.
when I first started in this business, I think it was 2001, the disaster victim identification unit at Victoria Police was one full-time person, one part-time copper, and they had a budget of $20,000 a year. Then the Bali bombings happened, and their budget, I don't know, grew exponentially orders of magnitude greater, and now there's something like 300 disaster victim identification trained policemen in the state of Victoria, a proper command structure and a whole permanent team devoted to disaster victim identification. So, but it really does take the disaster to happen before the bean counters will stand up and listen and devote some money your way.
When a suspicious death is referred to you, are there any instances where you haven't been able to determine the cause of death?
Sure, that does happen. The most difficult deaths you'd be perhaps surprised to learn are not the sort of complicated multi-trauma cases, but the cases where there is no trauma and no visible natural disease at all. We, in a pathology sense, can see anatomy, we can see structure. What we can't see is function. So we can't see how the heart is working. We can see if there's a problem, a disease in the heart that has left a physical manifestation on the heart. What we cannot see are some of those subtle functional changes, the arrhythmias, that are a purely functional event. But having said that, moving on to our genetic work for DNA, we can start looking for some of the markers that are linked to some of these functional changes. Now, finding the marker doesn't prove the person had that functional change, but it can give you a strong indication that that death, unexplained by anything else, may well have that as a solution. And a classic for that would be sudden infant death syndrome, for example. It's probably a multifactorial process, but it's very hard to pick on any particular thing.
As a scientist myself, I'm always amused when there's a depiction in the movies or series of terribly erroneous events depiction. So what laugh out loud, scientifically erroneous things have you seen in recent dramas or movies?
Okay. I think the classic for me was, I think it was CSI, or I don't know, one of those funny shows, and it was a bite mark case, so it was very dear to my heart. And they held up a photograph of a bite mark and an X-ray of someone's teeth and said, "See, clearly it's a match."
I always remember annoyed me was seeing people pick a bullet out of a wall with metal forceps. And the last thing you do is, transfer any scratches or marks on a projectile. So, when I'm removing a bullet, I actually like to use my gloved fingers. I just, I don't want any instruments to touch that object whatsoever to damage it.
I think mine would be, the classic recovery of bones in the hand sat perfectly, all intact. And of course, there are many, many small bones of the hand, and they are actually incredibly complex to recover and don't stay, in one nice bit.
I just like the fact that DNA scientists can do toxicology and do radiology and can,
entomology.
master of all trades.
Absolutely.
We all drink lattes and carry guns.
That's right, yeah.
The Bogle Chandler case.
Oh, yes.
Do you have any comments on what you would do today? Toxicology.
Yes, well, there's no toxicologists here, I'm afraid. I think the way we collect samples will be very different than that, because there was lots of interesting issues about gases and various other things there, and anything that's volatile or gas related is complex. I think the other thing is solid tissue structures, collection of those for toxicology analysis, although getting normal values for those are very, very difficult. So I think there are a range of things that would have been done today, plus the fact that the ability now to detect much lower concentrations of substances means that trace collection indicating prior exposure to other drugs might also have been a very useful resource in that case.
Ample information in the top scene you're trying to identify. And what do? Do you send pictures around to every dentist in Victoria?
No, it's quite...
Or are my dental records on file with the forensic institute?
They're all in my head. No, it's a common question. Are all our dental records kept on some common database that I can just access willy-nilly? I'm afraid not. They're all in your old GP dentist attic up in his roof somewhere if you haven't been to his dentist for 30 years. But so in order for me to identify someone by dental records, I have to have some idea of who that person is. So the police will have a believed to be name. They'll have found him in his house or in his car, or there'll be some information that will lead to a putative identity. So once the police know who they think it might be, then they'll contact his family, and his family will tell him who his dentist was, and they'll go to the dentist and get their records that way. Occasionally we can't. During Black Saturday we relied a lot on insurance companies. We've got special dispensation through the coroner to breach privacy legislation and interrogate insurance company databases. We can contact community dental services, the dental hospital, etc., etc. So there's a whole range of avenues where we can get the dental records from, but no, there's no central database, I'm afraid. That would.
And the reason for the bushfires was that all the records were burnt as part of that disaster.
A couple of dental surgeries that burnt down during the bushfires, which didn't make it very easy for us.
I was interested in this forensic anthropology, the discipline itself, and wondered, is it classified as a social science or a natural science?
It's the million-dollar question.
I'm interested because I'm a social scientist, and there's always this kind of methodological kind of rivalry or lack of belief, really, in each other's.
No, it's a very good question. I mean, certainly there's been great debate within our advisory group around mentoring and training for next generation, whether students should have an anatomy that is science background, or whether in fact people are better or differently placed having an arts. Many people did come from an arts background that provided a wealth of very valuable skills, but of course you don't necessarily then have their good anatomy. So we're looking really at trying to bridge both, and I think increasingly the nature of education is that you're not going down one particular line. I certainly would advocate that you do need good anatomy, but certainly the social side of your training is also extremely important.
At the last event, two of our interns, Rosie and Charmaine, took the initiative to conclude the event by thanking the efforts of scientists for the work that they do, particularly the researchers that appear before us. So I'd like to continue that, what will hopefully be a tradition, and really thank them for their service, because like our defence forces, our police force, emergency services, we rightly thank them for their service to the public, and I think we should remind ourselves of the incredible dedication that our scientists, and particularly our 4 scientists this evening, show to their work and to improve the lives of people in the community. So why don't we thank them for their service. Thank you very much. Thank you. Of course, these events would not be possible without the support of our partners, and the refreshments beforehand were made possible by the partners. The opportunity to invite outstanding speakers that we've heard this evening, and to ask them to engage and share their work with us. It's been an incredible session this evening. No one's left and people are still here, and you've really entertained us, but more importantly, you've showed us, I guess, the value of science. We take it for granted. We see news stories and we hear about the coroner and forensic medicine. We don't quite understand what it is. I think you've given us a far better appreciation and understanding of what actually is involved in your work. I'd like to thank also Andrea Fisher and her team at the Doherty Institute for making this incredible venue available. Thank you, Andrea. And to the Convergence Science Network interns. You would have met them when you came in this evening. They were hassling you for registrations and all that sort of stuff. So thank you, team. Thank you again. Please join me in thanking our presenters this evening. I look forward to seeing you at a future event. Thank you very much.